Hi all. Now we are going to explore one of the most useful concepts in science, that is density. Density helps us understand why some objects afloat while some others sink, why ships made of steel stay afloat, and even how engineers choose the right materials for buildings, vehicles, and spacecraft. Throughout this lesson, we will discover what density really means, how to calculate it, how to measure it for different materials, and how it influences our daily lives. By the end of this presentation, you will understand that density is much more than a formula. It's a property that explains many fascinating natural phenomena. So let's get started. So what is density? So density describes how tightly matter is packed into given amount of space. So what does density means? It describes how tightly matter is packed into given amount of space. So here you can see two materials, right? One is wood and another one is lead. And both of them are taken in the same size, right? So you can see how the particles are packed in the wood, right? So there are some space in between. But what about lead? It's very closely or very tightly packed, right? So objects with a higher density contain more mass in the exact same amount of space. Every material possesses a unique characteristics called a density. So that is what we meant by density. Okay, so that is what we have shown here. So basically imagine two cubes that are exactly the same size as you can see here, right? Exactly the same size. One contain only a few particles while other is packed with many particles. Although both cubes occupy the same volume, the second cube has much more mass. So this cube you can see, right? The mass is comparatively very high. So therefore, the second cube has a greater density. So the second cube has a greater density. So density is an intrinsic property of matter. This means it does not depend on amount of material present. Whether you have a tiny gold ring or a huge gold bar, gold always has the same density under identical conditions. So scientists use density to identify unknown substances, compare materials, and predict how objects behave in fluids. Okay. So how will you calculate density? Density is calculated using a simple relationship. Density equals mass divided by volume. So mass by volume, right? So the formula is density is equal to mass by volume. So the triangle shown here is an easy way to remember the formula. Okay. So if we cover density, mass equals density multiplied by volume, right? And if we cover mass, density equals mass divided by volume. Okay. And if we cover volume, volume equals mass divided by density. Okay. So the SI unit of density is kilogram per cubic meter, written as kilogram per meter cubed. In laboratories, gram per cubic meter, centimeter are also commonly used. Okay, now let's see one example. Okay. So just imagine that there is a copper block which has a mass of 89 grams. Okay, so mass is given here, right? That is 89 grams. Okay, and occupies 10 cubic centimeter. So its density is 89 divided by 10, which is 8.9 gram per cubic centimeter. So this was density and this was the this was mass. So here we have provided the mass and uh, the volume, right? So the density will be 8.9. Okay, clear? So for finding the mass, what you can do? You can multiply density into volume. You will get mass. Okay, is that clear? And for finding the volume, if mass and density is provided, you can divide mass by density. So you will get volume. Okay. Now let's see the reference densities. Water serves as the standard reference for density. Pure water has a density of exactly 1 gram per cubic centimeter at 4 degree Celsius. Okay. So we'll be taking water, the density of water as a base. Okay. So materials with densities lower than 1 generally float on water. So you can see many things that will float on water, right? So those will have density uh, less than 1. And materials with the densities greater than 1. So we'll be taking water as the mark, right? So densities less than water will flow and densities greater than water will sink. Okay, clear? So air has an extremely low density, right? So ice is slightly dense, less dense than the liquid water, which is why ice floats. And wood often float because its density is lower than water. Most rocks and materials sink because their densities are much greater. So it is the reason. So understanding these reference value help us predict the behavior of different materials. Okay. So this is the density of pure water, right? So we have less density like air, wood, ice, ethanol, etc. And there are materials that have greater density, that are glass, iron, mercury, gold, etc. So they will sink in water and these will float in water. Now let's see the laboratory equipment. Okay, so there will be different equipments in a laboratory, right? Let's see. So the type, like if the material is a regular solid like cubes, cylinders, etc., the mass tool will be balance. Okay. And what about the volume? You can use ruler or caliper. And we'll be using geometrical formula to find the values needed, right? And what about irregular one like stones, pebbles, etc.? We can use balance. And we'll be using the measuring cylinder. Okay. So we'll use the method liquid displacement. How much liquid will be thrown out, right? Or overflowed. And then for liquid, we will also use balance and measuring cylinder. Mass subtraction will be used. And for air, the tool is balance and we'll be using flask. Vacuum extraction is the technique. Okay. So let's see how to find the density of regular solids. Okay. For regular shaped objects, determining density is straightforward, right? First, measure the object's mass using a laboratory balance. You can easily calculate the mass using a balance, right? A weighing machine. Next, measure its dimensions like length, width, and height. You have to measure the length, width, and height. Okay. Then, calculate the volume using the appropriate geometric formula, right? So, you'll have to use the formula. So, that is mass divided by volume will give you density, right? Finally, divide the mass by volume. That is what we have to do. So these methods work well for cubes, rectangular blocks, cylinders and spheres because their dimensions can be measured accurately. Okay. Now what about irregular solid? So it is very easy for regular solid, but we also have irregulars, right? So let's see how to measure them. Not every object has a regular shape, like pebbles, keys, statues, and many natural objects cannot have their volume calculated using geometry. Instead, we use the water displacement method. First, record the initial water level. So, for example, let's take it as 50 milliliter. Okay, 50 ml. Then, carefully immerse the object. You have to put the object inside the water in this measuring scale pot. Okay. Then you can see the rise in the water level, right? The volume displaced. See, this is the final reading and this was the initial one. So you have to record the final water level. Then the difference between the two readings equals the object's volume. So the displacement, no, this volume displaced will be the uh, density or the volume. Okay, we are mentioning about the volume. It will be the volume of the product. So object volume is equal to final reading minus initial reading. Okay. So it is a simple technique. Okay. And the scientists like Archimedes over 2000 years were used it. Now let's see the other one, that is overflow method. So when an object is too large for measuring cylinders, or like not all objects can be measured using the cylinders, right? Measuring cylinder. So we can use an overflow can. Okay, this is an overflow can. So first you have to fill the water till the top. Okay, like this. Then the object is submerged like this, and the displaced water overflows into another container. Finally, this water is collected and measured. Just measure the collected water. Okay. So the volume of displaced water is exactly equal to the volume of the submerged object. So this method provides accurate measurement for larger irregular objects. Clear? Now let's see density of liquid. So we have found the mass, volume, etc. Now let's find the density. Measuring the density of a liquid requires separating the mass of the liquid from the mass of its container, right? First, you have to weigh the empty container. Okay, just take the mass of the container. Then fill it with the liquid and weigh it again. Okay, so subtract the mass of the empty container from the total mass. So the total mass will include both the cylinder's mass and the liquid's mass, right? So you have to minus empty container's weight, the mass from the filled one. Okay, then only you will get the actual mass of the liquid. So measure the liquid's volume using a graduated cylinder. Okay. So finally divide mass by volume to obtain density. So you can divide mass by density, sorry, mass by volume to obtain density. Okay. This is the formula for density. Now let's find the density of gases. Okay. Gases have very low densities, making measurement more challenging, right? The density of gas is very low. So scientists use sealed flasks with the known volumes. Okay, sealed flask with the known volume. So first we have to take an empty flask and it will be weighed like this. Okay, then it is filled with the gas. Then you can fill the gas, and the increase in mass equals to the increase of, sorry, the mass of gas. Okay, so after that, after uh, filling with the gas, you have to weigh it again. The difference will be the mass of the gas. Okay. So since the flask volume is already known, density is calculated by dividing the gas mass by flask volume. So gas density changes significantly with temperature and pressure. These conditions must always be controlled. Okay, so mass of air is equal to initial mass minus vacuum mass, right? And volume is equal to the known capacity of the flask. And you can easily find the density. Now let's see density and buoyancy. Okay, buoyancy depends on the relative densities of objects and fluids, right? If an object's density is greater than the fluid's density, it sinks. If the object density is lower, it floats. Okay, so if both densities are equal, the object remains suspended. So this explains why ships float, fish can swim at different depths, icebergs float, hot air balloons rise. So submarines control their buoyancy by adjusting the amount of water inside ballast tanks, changing their overall density. Okay. Density also explains buoyancy at the particle level. Inside a liquid, pressure increases with the depth, right? So, the bottom of an object experiences greater upward pressure than the top. So this pressure differences create a buoyant force. So if the buoyant force exceeds the object's weight, it rises. Okay. If its weight is greater, it will sink. So buoyancy is simply a result of pressure differences within the fluid. Okay, so this is normal water and this is Dead Sea water. You can see the salt particles, right? So high amount of dissolved salt drastically increase the mass within the water's volume. So higher density water provides significant greater thrust, right? That is the buoyant force. So what will be the result? Human body floats effortlessly because the relative density of the water has exceeded the average density of the body. So that is why you can float in the Dead Sea water. Now let's see the applications of density. So we have a lot of applications, right? So density plays an important role across science and engineering. Naval engineering designs ship using density principles and the submarines. Okay. Submarines control uh, depth by changing their average density. Okay. Then geologists identify minerals through density measurements, and medical professionals use density in body scans and bone density testing. And food industries monitor the density of milk, honey, and cooking oils. Chemical industries separate mixes based on density differences. And environmental scientists study ocean currents created by differences in the water density. And from laboratories to ocean, from hospital to aerospace engineering, density remains one of the most practical and powerful concepts in physics. I hope it is clear for you. Thanks for watching.